Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. Now let's get into the first practice question. The question says, the following compounds are given with their corresponding boiling point. Now, this question is extremely very easy. I know now you are looking at the question, you are seeing that the question is very long, but it's very simple. So listen carefully to the way I'll be analyzing this question, and at the end of solving this particular question on the board, I will give you your own practice question to master how to solve questions under this aspect in chemistry. Is very simple, so watch closely. You can see I stopped here. I'll read the question again, so you just listen. I saw a very important word in this question, and that word I saw is simply called boiling point. So now I take the question again. The question says, the following compounds, we'll get to know the compounds we are talking about, so you just listen. The following compounds are given with their corresponding boiling points. Alright, you can see I've noted this. Let's progress. You can see now they said the compounds are, alright, this Roman figure 1, Roman figure 2, Roman figure 3, Roman figure 4, Roman figure 5. They just told us that these are the compounds, though they were not really specific about the compounds. They just say, okay, they just signify the compounds with Roman figures, all right? So basically, let us progress. And their respective boiling points, all right? I saw this again. And their respective boiling points are, all right, you can see different boiling points. In this question, this is 14 degrees Celsius, 24 degrees Celsius, 0 degrees Celsius, 120 degrees Celsius, and minus 2 degrees Celsius. Just relax, all right? From the above informations, all what we've read, from the above informations, all right, indicate which of the following options is correct. So this question is simple. You just relax. I'm going to analyze and tell you what to do to solve questions under this aspect. I'll give you a similar question so that you can master this aspect of chemistry very well. So you can see we're giving different options. Just relax. I will explain. Now, first of all, in this question, I saw this key term called the boiling point. So the first question we ask ourselves, what is boiling point? Now, this is very simple. What's boiling point? Now, listen. Boiling point is a temperature. You can see I mentioned temperature. You can see in this question, we're giving different temperatures of different compounds. So I'm telling you now that on definition, boiling point is the temperature, or it is a temperature by which a substance, all right, this substance can be anything. It can be this marker, all right. So by which a substance changes, this definition I'm giving to you is like the simplest definition you should know about boiling point, and knowing that will help you solve this question. So boiling point is the temperature, or it's a temperature by which a substance changes from liquid to gaseous state. Listen, boiling point is the temperature by which a substance changes from what? Liquid state. Listen, liquid state to what? Gaseous state. So this is what you should take note of. So I believe you are getting what I'm saying. You just relax, because I just explained to you that boiling point is a temperature at which a substance changes from liquid to gaseous state. And now we were given the temperatures or the boiling point. You can see now I can say temperature, boiling point are literally the same. Boiling point is a temperature. If I were to talk about another terminology called melting point is still a temperature, but we are not talking about right now. We are focusing on boiling point based on the question. Now you can see I've explained to you what boiling point is. Now before I analyze the question, let us quickly read all the options. You can see option A says all the compounds are gaseous at 20 degrees Celsius. Just relax. You can see that we were given different compounds. Now, option A is not telling me that all of these compounds, Roman figure 1, Roman figure 2, 3, 4, and 5, they are all gaseous. So you can see where the question is coming from. So they gave us different statements. They are not asking us which of them is correct based on all of these informations. So we have to understand what we are doing here, and it's very simple. Just watch the way I'll be analyzing this question, because actually you can see option A says all the compounds are gaseous at 20 degrees Celsius. How did I even know? How will I know that all of these compounds are gaseous, are in gas form? How will I know? That will be the question you ask me, because this one that is here can be liquid, can be gas, can be solid, but I will tell you how to know the state of matter of this compound, because option A is telling me that all of them are gaseous at this temperature, 20 degrees Celsius. Option B is still telling me here that two of the compounds, so two out of these compounds are gaseous at the same temperature. So you can see that they are focusing on this particular temperature, 20 degrees Celsius, 20 degrees Celsius. Option C now said that three of these compounds are gaseous at this, all right, three of the compounds are gaseous at, all right, it should be at 20 what degrees Celsius as well. So the question we ask ourselves, how will I even know that two, three, or all of them are gaseous, or none of them are gaseous at this temperature? How will I know? Simple. So I'll be using an analogy to explain how to know the compound that will be gaseous at this temperature, 20 degrees Celsius. It's very simple. Just listen carefully. So here's the analogy. Let's say this is a track race, and I believe you know that every track race has a finish line. Listen, let's say here is the finish line, and let's call this finish line a particular temperature, and that temperature I'll be calling the finish line is 20 degrees Celsius. Because the options, if you see the options, they're not saying that all of the compounds are gaseous at this temperature, two of the compounds are gaseous at this same temperature, three of the compounds are gaseous at this same temperature. So that 20 degrees Celsius, I'm going to call it the finish line. Just relax, I'll be analyzing the question. Now remember, I believe we know here that every track race has different runners. These runners, in this case, they are the compounds with different temperatures. Just listen. And these temperatures are the boiling points of these compounds. So let's start with the first, which is 14 degrees Celsius. Is part of the runners, which is the first compound. Another temperature here is 24 degrees Celsius. Relax, they are all very simple. Another temperature here is 0 degrees Celsius. Another temperature here is 120 degrees Celsius. And another temperature here, which is the last temperature, is -2 degrees Celsius. So all of these temperatures are the runners to partake in the track race. So you just relax to the way I'm going to analyze this question. So we'll get our answer to this question. At the end of solving this question, I'll give you a practice question to solve to master this aspect very well. Now, this must be noted. Remember that I told you guys that I did not actually tell you is on the board. All of these temperatures are the boiling points of the compounds, because we were just given the compounds. Now, from the question, from understanding of the question, what they are actually asking us to determine is to determine the compound out of the 5 compounds we are having here that is a gas at 20 degrees Celsius, which is the finish line in this track race. You just relax. And I said here that all of these temperatures are the boiling point. They are the temperatures to which these compounds should start boiling. So for instance, when we get to 14 degrees Celsius, this compound A should have started boiling, and also when that compound starts boiling, I believe you know here that it should turn into a gas, because the boiling point is the temperature at which a substance changes from liquid to gaseous form. So this 14 degrees Celsius is the temperature to which this compound should start boiling. This 24 degrees Celsius is the temperature to which this compound too should start boiling. 0 degrees Celsius is the temperature to which compound 3 should start boiling. I believe you understand what is happening. They are all very simple. They are not difficult at all. So now let's get this straight. It's very simple. So let's say all of these runners are partaking in the race. You get. So this runner 1, this is the first runner, and its temperature to which it should start boiling, to which it should change into a gas, is 14 degrees Celsius. And this is the finish line. So let's say this guy is running towards 20. I believe you know here that in every track race we have the starting line and the finish line. So since it's 14, before it gets to the finish line, compound A should start boiling, because the boiling point is 14 degrees Celsius. This compound A, this first compound 1, should have turned into a gas. That is why 14 degrees Celsius for compound A definitely is a gas at this 20 degrees Celsius. In all of the options, you just relax, because I said here that boiling point is the temperature, because you have to understand what boiling point is to analyze the question. It is the temperature to which a substance starts boiling. You understand? It is the temperature to which a substance changes from liquid to gas. You understand? So being 14 degrees Celsius, relating it with the 20 degrees Celsius, they are asking us to relate it to based on the question, which is the finish line. Before this first compound 1 get to the finish line, it should have become a gas, because the boiling point of the compound, specifically compound 1, is not even up to the finish line. So before this guy gets to the finish line, it should have become a gas. You understand the point I'm trying to make? It's very simple, because it's a boiling point. So being 24 degrees Celsius, you can see 24 degrees Celsius here. You can see already this compound being 24 degrees Celsius is telling us that for this compound to start boiling, it should be 24 degrees Celsius. So you can see here that it is 24 degrees Celsius. And what is the finish line again? 20 degrees Celsius. So you can see 24 degrees Celsius will definitely exceed the finish line for it to start boiling. So this compound being 24 degrees Celsius cannot be a gas at 20 degrees Celsius. It cannot be a gas, because it has exceeded the finish line. So for it to start boiling, this compound 2, for it to start boiling, it should be at 24. And the finish line is 20. So you can say it will pass before it start boiling. So you can say the question is specifically at. So for you to be a gas, based on this question, you must be a gas at 20 degrees Celsius or below 20 degrees Celsius. I believe you understand it. At or below, that's how it works. For a substance to start boiling, it should boil below the given temperature to which that compound should boil, or at that temperature. If it exceeds it, then that substance, because you can see all of this temperature now, you can see 24 has exceeded 20. Because for compound 2 to be, which is 24 degrees Celsius, for it to start boiling, it will exceed the 20 finish line, the 20 mark. So that's not correct. So this, which is 24 degrees Celsius, is actually a liquid. It's still a liquid. Do you understand? Because for it to start boiling, based on the information, it boils at 24. I believe you understand what is happening. They are all very simple. Because at the end of some of these questions, I'll give you your own to analyze, and they are all simple. Now, moving over to the next compound 3, and what's the temperature to which it should start boiling is 0 degrees Celsius. Wow. You can see before this compound even gets to 20, the boiling point is 0 degrees Celsius. So definitely it should start boiling before it even gets to 20. Then we are correct. Then this compound 3 is a gas. You understand, at 20 degrees Celsius, because before it gets to 20 degrees Celsius, it should start boiling. I've explained everything for you. You will get to that temperature 20 mark or below the mark, you should start boiling based on. But if it's above that 20 mark, then you are still a liquid. You are not yet a gas based on the question, because the question is dwelling on boiling point. You understand? They are all very simple. So moving over to 120, you have 120 is very far. You can see for this 120 degrees Celsius, from this information, the compound 4 being 120 degrees Celsius should start boiling at 120 degrees Celsius, and the finish line is 20. You understand? So you can see before this compound 4 start boiling to become a gas, it must get to 120, and that is very far. So then this compound 4 is still a liquid. It's not yet a gas at 20. It should be at its mark. You understand what is happening now? I believe everything is clear. Now, moving over to the last boiling point of, this is for the fifth one you get. So you can see -2. Wow. So they are telling us here that this compound 5 boils at -2. Wow. So before even this -2 get to 20, because it's -2, -1, 0, 1, 2, 3. So before I get to 20, it should start boiling, and that is what we want. But if the number is above that mark given to you in the options, then it's not correct. Then that one is still a liquid. I believe you understand what is happening. All these are very simple. So if you observe, -2 degrees Celsius, this compound 5 boils at -2. So then it's okay, it's a gas. It should be a gas before I even get to the 20 mark. So this is a gas. You understand? So based on all the analogy analysis, you can see here that we have 3 compounds that is a gas at 20 degrees Celsius. You can see how it works. So that is why the answer to this question should be option C, because we had 3 compounds that were gases at 20 degrees Celsius. You can see some of them, before they even get to 20, they start boiling, so they become a gas. You understand? But you can see all these ones that are above the 20, no, they will not become a gas yet. They must reach that mark before we call them a gas. So they are still liquid. These are still liquids. I believe it's clear, it's very simple. Okay, guys, let's get into the next practice question. Before we get into the next practice question, I'll give you one practice question. So let me just change the informations. Let's say this is 30, or let's say this is 36. Let's say this is 5. Let's say this is 50, and then let's say this is -6, and the mark we are the temperature to which the substance start boiling, let's say it's 40. All right, I'm going to call it 40 degrees Celsius. So you should tell me the answer to this question. I've given you all the concept. For a substance to start boiling, it should boil at this temperature or a temperature below it. You understand? That's what boiling point talks about. So you should analyze all the boiling points given to us and tell me the one that is a gas at these temperatures, 40 degrees Celsius. They are all very simple. All right, I've seen the answer already. Now, like, don't choose any option. Just tell me. You tell me that, okay, 2 will be gaseous at this 40 degrees Celsius. 3 will be gaseous. 4 will be gaseous. 5. Tell me the one that will be gaseous. The numbers of compounds that will be gaseous at this 40 degrees Celsius. So tell me in the comment section. They are all very simple. They are not difficult at all. So now this question actually should be question 6. The one you are solving is question. So write 6, put the answer. Let's go over to question 2, 3, 4, 5. So then I will now start from 7. This is your 6th question. So question 2.
Have more understanding about chemistry calculations and solving all of this type of questions. I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
Which of the following is a mixture? Wow. Which of the following is a mixture? What's a mixture? All right. So the question is, they are asking us which of the following options is actually a mixture. What's a mixture? That will be the question you ask yourself. I don't want to make it very look so serious, because it's very simple. Now listen. A mixture is formed, listen very well, by the combination of 2 or more substances. Let's say this is a substance. Let's say my hand is also a substance. So combination of 2 or more substances whereby each of these substances that are being combined together still retain its identity. Let's say, for instance, this is a marker, this is my finger. Then I bring them together. You can see I've formed a mixture. But at the end of forming that mixture, what you used to form the mixture still retain their identity. That's what a mixture is. Very simple. Then option A is sulfur powder. Sulfur powder is not a mixture. It's still an element, because you can see that sulfur is an element. And sulfur being an element is symbolized as S. So this is an element, not a mixture. You can't call it a mixture. Option C, distilled water. Water itself is a compound. It's not a mixture. Option D, ethanol. Ethanol is a compound. It is not a mixture. Mixture, you are combining two different things. Listen, bronze is the answer to the question. Bronze is a mixture. It is formed, bronze specifically is formed by combining two elements together. And the elements we are combining together is copper and tin, SN. Listen, please don't mistake it with a compound being formed by the combination of elements. Compounds are formed by the combination of elements, and these elements are combined chemically. Listen very well. Bronze is a mixture, it's something you should know. This sulfur powder is an element because it's literally sulfur being an element. They just change it to sulfur powder. These ones are compounds. Water, you should know that water is a compound. You should know that ethanol is a compound, even if you don't know the chemical formula, because compounds have chemical formula. And these guys, I don't want to write the chemical formula. It's best you know how it was written, not just writing it. Though I know the chemical formulas of these guys, you get. So bronze actually is a mixture, but to be specific, bronze is a metallic mixture because it is formed by metals. As we are having bronze, so we are having another mixture like brass. Brass is also a mixture. It looks like bronze. Brass is a mixture that is made up of two elements which are copper and now in this case zinc. Please memorize this because these are possible questions that will come out in the JAM exam. So if they ask you between brass and bronze, which is the base metal that forms its constituents, it is copper. You can see that copper is common between them. So copper is one of the most important here. You get, they are all very simple. So the answer to this question number 2 is actually option B. It is not just bronze or brass we have as metallic mixtures. We have so many other metallic mixtures whereby in the course of this video lesson, I'll be talking about them in questions. So you just relax. Anything I've said, please take note of them. They are very, very important. Let's get into the next practice question, and it's question number 3. It says, the acid used to remove rust from metals, that acid is HCl and it's pronounced as hydrochloric acid. Listen, they are all very simple. Now let's get into the next practice question. Question number 4, it says, from the above question, which is question number 3, the process is called, so they're not asking us, the process whereby an acid is used to remove rust from metals, what is it called? It's simply called pickling. What did I say? Pickling. Let's get into the question number 5, and it says, the acid industrially produced by contact process, that acid is H2SO4 and it's called hydrogen tetra. Tetra because we have 4 oxygen. Tetra oxo sulfate 6. There is a reason why that 6 is there. It's done by you understanding the concept of oxidation number, which I already have in some video lessons here on YouTube. I'll be bringing out a video here so you can watch that video. You just check out my playlist and you see the video, search for the video. You see the video where I explain how to solve oxidation number from scratch till the end. And you know why it's actually sulfate 6. You understand? Hydrogen tetraoxo. We have 4 oxygen. If it's 3 oxygen, I'll say trioxo. But it's 4. That's why it's tetraoxo sulfate 6. There is a reason. Go watch this lesson to learn the reason. So let's get into the next practice question, which is question number 7. Because I've given you a practice question. This is question number 6. So we'll start from question number 7 down till the end of this lesson. So if you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons with your friends. Let's move on to more practice questions. Okay guys, let's get into the next practice question. And it says, an heterogeneous mixture is what? Very simple. An heterogeneous mixture is a mixture whose composition is not uniform. So it's a mixture whose composition is not uniform. So it means that in heterogeneous mixture, what makes up heterogeneous mixture are not uniform. We have 2 types of mixture on this aspect. We have homogeneous mixture, that are mixtures whose composition are uniform. Heterogeneous mixture, as seen in this question, their composition is not uniform. Like a good example of an heterogeneous mixture is you mixing oil and water. You taking oil and pouring that oil into a glass of water or a bowl of water. You see that the oil will be up. It actually will not mix. So that's heterogeneous. Homogeneous mixture. A good example of an homogeneous mixture is you taking sugar or salt in water. It will actually mix and the sugar or salt will actually dissolve very well. So that's an homogeneous mixture. I believe you understand what's happening now. It's very simple. Now, moving further, let's get into the next question. And it says, What is octane number in chemistry? Now, octane number is a very important aspect of chemistry that measures how the fuel in a particular engine resists that engine from knocking. Are you there? So that's what octane number is all about. We have engines that have higher octane numbers and engines that have lower octane numbers. Those engines that have very high octane number is due to the quality of the fuel that makes up, that is part of the engine. So those engines are much more powerful. Engines with higher octane numbers are much more powerful than engines with lower octane numbers. Examples of engines we have with higher octane numbers are those, cars used for sport activities, whereby engines with lower octane numbers are examples of those regular cars you see around. So those cars, they have lower octane numbers than those cars that have higher octane numbers, those cars used for sporting activity. You understand? Now let's get into the next practice question, and it says calculate. So it's a calculation question. Calculate the number of moles of this compound present in 20 grams of it. Is very simple. All right, so first of all, for you to solve this question, you have to know the atomic masses of the element making up the compound. We have two elements here, and they are calcium and chlorine. The atomic mass of calcium is 40. The atomic mass of chlorine is 35.5. I'm not going to solve this question. This question is very simple. This question is from the aspect of chemistry called mole concept stoichiometry. And if you are a student still finding this aspect of chemistry very difficult, I already have a full video lesson which is over an hour. You get, I explained everything you must know about stoichiometry from the scratch till mastery. If you've watched the video, you can comment down that you've watched the video. If you have not yet watched the video, make sure you go watch the video. The video will be here on the screen, so you can go search for the video and watch the video on my channel. And I've made everything you must know about how to solve questions under this aspect stoichiometry so easy. All right, so you should not have problems solving this question. So after watching that lesson, come back here and comment down the answer to this question. If you've watched that lesson, fine. Answer this question. Is very simple. I'm not going to answer it. You will be the one to answer the question. So let's get straight into the next practice question. The question says the equation PV is equal to nRT signifies which gas law? All right. The law that this formula signifies is ideal gas law, or we can simply say the ideal gas equation. The equation is PV is equal to nRT, whereby P means pressure, V means volume, N is number of moles, R is a constant called the molar gas constant, and T is temperature in Kelvin. Also, I already have a full video lesson here on my channel that explains everything you must know about gas laws. So go watch the lesson here as well. And meanwhile, even this formula, this concept was even solved in the video lesson I have on my channel on stoichiometry. So any question that has to do with stoichiometry, you should not have problem with it because I've made everything so easy. So make sure you watch that lesson to learn everything you must know about that aspect of chemistry. Let's get into the next question, and it says, discovery of the nucleus of an atom was by. The answer to this question becomes Lord Ernest Rutherford. It is Lord Ernest Rutherford that actually discovered the nucleus of an atom. I believe you know how an atom looks like. Let's say this is an atom. All right, all of these cycles, they are like shells, and the nucleus of an atom is centrally located. Remember, an atom has, this is an atom. All right, an atom has three important subatomic particles which I call pen. All right, P-E-N. And what are they? P means protons, E means electrons, and N means neutrons. All of these subatomic particles, they are found inside the atom. Like I said, that this is the nucleus, and you must take note here that the nucleus contains two out of the three subatomic particles, which are protons and neutrons, whereby electrons revolve around the orbits, revolve around the nucleus. So this is where electrons are found. All these things that I signified as this, you understand, they are the electrons. Are you there? And all of these subatomic particles, they have charges. Protons, generally, they are positively charged. Electrons, they are negatively charged. And neutrons are neutral. I believe you are following me. All these are very simple. So you should know here that the nucleus of an atom was discovered by Lord Ernest Rutherford. And also for these protons, electrons, and neutrons, they also have their discoverers, which I'll be talking about in the course of this lesson as well. But let's just focus on this nucleus. You should know here that it was discovered by what? Lord Ernest Rutherford. Let's get into the next question, and it says, discovery of cathode ray was by. Now, you should know here that the cathode ray was discovered by a man called William Crook. So you should take note of that. William Crook discovered the cathode ray. Question number 13, it says, discovery of anode ray. All right, anode ray was discovered by a man called Eugene Goldstein. Take note. Eugene Goldstein discovered the anode ray. So let's get into the next question. Question number 14 says, atomic number was discovered by a man called Henry Moseley. Please take note. Henry Moseley discovered atomic number. All these are very important. Moving over to the next question, discovery of symbols to classify elements. All right, you knowing that hydrogen is symbolized as H. It was done by this man. He brought about symbols to classify elements, and that man's name is called John Jacob Berzelius. Are you there? Let's get into the next practice question. Question number 16, it says, discovery of the Plum-Puddy model of an atom was by. So first of all, you have to know what Plum-Puddy model of an atom talks about. First of all, you should know here that it was discovered by a man called J.J. Thomson. That's the man that discovered it. But you should know what this model, this aspect of chemistry from 11 down till the end, I focus on the atomic structure. So whenever you have Plum-Puddy model of an atom, it is a model that talks about that. All of these models, they were trying to describe how an atom should look like, in early days. So now this Plum-Puddy model of an atom, which I'm talking about now, was brought by J.J. Thomson. So this man, J.J. Thomson, now said that he was trying to describe how an atom should look like. You understand? You can see I describe this atom in this way. This J.J. Thomson was trying to describe how an atom should look like back then. So now he said that an atom is a sphere. Wow. He told us here that an atom is a sphere that is made up of positively charged matter. An atom is a sphere that is made up of positively charged matter. That was what he was trying to say that time in the olden days. So you can see what he said. An atom is a sphere that is made up of positively charged matter, inside of which this positively charged matter, we have embedded electrons. And you can see here that I've explained to you here that electrons are negatively charged. So he said that inside this sphere where we have positively charged matter, inside them we have electrons that are embedded inside this atom with positively charged matter. So you can see now that electrons are negatively charged. So then this how he described his own atom. But that was not enough because it had some limitations. Are you there? One of the limitations is that I could not explain what we call the large angle scatter using the alpha particle scattering experiment. But I'm just telling you in the case of the JAM exam, but it's best for you to understand properly what is happening, but you should know it. One of the limitations of the J.J. Thomson's atomic model, which is called the Plum-Puddy model of an atom, which I've explained to you, is that it could not explain the large angle scatter using the alpha particle scattering experiment. Some other scientists brought about their model, like likes of Rutherford. This man also brought about his model, which is the planetary model of an atom, and that talked about something. Rutherford still tried to describe an atom, you get. But I'm not talking about it in full. I'm just telling what you should know for the sake of the JAMB exam, you get. Please note all this. Well, you can say I said that the limitation of J.J. Thomson atomic theory or model is that I could not explain the large angle scatter. Please know it, but it's best to see the way I should explain it. But I'm not explaining the topic atomic structure in depth now, you get. So all this must be noted. Now let's get into the next practice question. Question number 18, it says, discovery of the specific charge. All right, no, 17, it says, discovering of the charge of an electron using the oil drop experiment. Please take note, whenever you hear discovery of charge of an electron using oil drop experiment, it was done by a man called Arrow A. Millikan, Robert Andrew Millikan. Take note. Robert and Millikan discovered the discharge of an electron using the oil drop experiment. But who now brought about the specific charge of an electron? It was done by this man. All right, what's that man's name? J.J. Thomson. J.J. Thomson talked about the specific charge of an electron. So let's get into the next practice question, and it says, the modern periodic law was brought by who? You should know this. It was brought by a man called Henry Moseley. You know, we have the modern periodic law and the olden days periodic law. The modern periodic law states that the properties of elements are in periodic functions of their atomic numbers. Of their what? Atomic numbers. That is why I told you here that atomic number was brought about by Henry Moseley. And he was the one, you can see brought about atomic number, and he was the one that brought about the modern periodic law as well. Please take note of all these, they are very simple. Let's get into the next practice question, question number 20, and it says, X-ray was discovered by who? It was discovered by a man called Wilhelm, not Williams now, Wilhelm Röntgen. This is the man that brought about the X-ray. Take note. All these are very simple. Let's get into more practice question. Okay, guys, let's get into the next practice question, and it says, determine the maximum number of electrons in the M shell. All right. First of all, it is very important for me to tell you where this question is coming from. This question, you can see, like, I asked so many questions that are like they are similar. So it's on a very important aspect in chemistry, and that aspect is called quantum numbers. I already have a full video lesson on my channel where I explained everything you should know about quantum number from the beginning till mastery. Here is the video, but watch how I'll be solving this question. At the end of watching this video lesson, make sure you go watch that lesson on quantum number to understand other things you must know under the topic quantum number. So if you observe what is happening here, this question is asking us to determine the what? Maximum number of electrons in the M shell. So what you should take note here is that they are specifically asking us to get the number of electrons or the maximum number of electrons in a shell. That's what I want you to know. So whenever you are asked, determine the number of electrons in a shell, because we have different shells. So in this context, they are asking us for the M shell. We have other types of shell, but you should understand here that whenever you are asked to calculate the maximum number of electrons in a shell, there is a formula to be used. And that formula is simply 2n squared. Are you there? Whereby that n you are seeing there tells us the number for the shells. In chemistry, we have different shells. The shells include the K, L, M, N shell, even the O shell as well. So all of these shells have numbers, and these numbers are determined by n. In that lesson, I get different quantum number because n is called the principal quantum number, because it is the principal quantum number that determines or describes shells. So that n for principal quantum number is one that gives all these shells their numbers, and the number starts from 1. So you should understand here that for the K shell, n is 1. For the L shell, n is 2. You understand, they are counted serially, and it starts from 1. So for the M shell, n is 3. For the N shell, n is 4. Don't mistake them. Oh, the small n is principal quantum number. This big N is called the N shell. This O shell. So for n, what's the O shell? It is 5. You can see what is happening. All of this tells us the n values. So for the first question, determine the number of electrons in the M shell. So you go for the M shell and look for the n value for the M shell. What's the n value for the M shell? 3. So then for the M shell, n is equal to 3. So using the formula to get a maximum number of electrons, it should become 2, open bracket, n is 3, close bracket, raised power of 2. So you should solve bracket first, bod mass. So 3 or raised power of 2, what's that? That's 9. 3 times 3 is 9. So then we are having 2 times 9 altogether. We are having 18 electrons. So the maximum number of electrons that should be in the M shell is 18 electrons. I believe it is clear. It is very, very simple. So you can see that is why I gave another question, and this question is for you, so you can use to master the aspect. Read your question. You'll get to a part where you will see a little change in the question. The question says, determine the maximum number of electrons in the L shell. So they are still talking about shell. So the formula still remains the same. You go for your L shell, look for the N value 2, and then solve the maximum number of electrons. So you should solve for 22. 23, this is another way the question can come. Determine the maximum number of electrons when N is 1. So they gave you N specifically. They told you N is 1, so get your electrons. So remember, you know that N is your shell. So they are still asking you indirectly to determine the number of maximum number of electrons in a shell, because N tells us the shell. You understand? Anything that has to do with maximum number of electrons in a shell, the formula is 2n squared, but it's going to change right now. So look at the next question, question 24. It says, so answer question 23, 22 for me and provide the answer in the comment section. Question 24 says, determine the maximum number of electrons in the p orbital. Wow. You can see now that question 24 is talking about you determining maximum number of electrons in an orbital. In an orbital. In an orbital is very simple. It's done by a formula, and I will tell you the formula. Okay, guys, before I give you the formula, I should tell you the orbitals we have. Not just the p orbital. We have other orbitals in chemistry. Alright, these orbitals include the s orbital, the p, sp, the d, f, g, h orbitals. All of these orbitals has shapes and names. But we should understand what is happening here, because what gives rise to orbitals is the azimuthal quantum number, and it is denoted as L. And for we to get the azimuthal quantum number, it starts from 0. So you can see here that the L value for the s orbital is 0. And it's counted serially as well. The L value for the p orbital is 1. You get. The L value for the d orbital is 2. The L value for the f orbital is 3. You can see what is happening. And here is 4 and here is 5. So all these are the L value for these orbitals. So now you can see that the question is asking us to determine the maximum number of electrons in the p orbital. Now there is a formula to be used, and the formula is simply 2L plus 1. Alright, so 2L plus 1 is the total, is the formula. But at the end of getting your answer, you times it with 2. They are all simple. They are all simple. They are not difficult. See what I said? The formula is 2L plus 1 times 2. So your answer, you times it with 2. That's it. It's very simple. See, look at what I said. You can see that the question is determining maximum number of electrons in what orbital? P orbital. Because look at your formula, you have L in it, that's small l. So what's the L value for the p orbital? What's the L value for P? Tell me. 1, 1, 1. L value for the p orbital based on this question is 1. So L is 1. So let's solve. 2 into L. 2 into L, what's that? So it's going to be like this. You put the L in the bracket. So 2 into 1 plus 1. Remember, you times everything with 2. Hope you're understanding. They are not difficult. I solve for the everything inside the bracket, and that times the 2 is outside. So 2, don't confuse it. It's very simple. 2 into L. L is 1 for the p orbital. You understand? P orbital, L is 1. P orbital, L is 1 for the p orbital. If for d orbital, what become L? 2. So this place I put bracket should be 2 for the d orbital, for instance. So you can see what's happening. Let's solve it carefully. So 2 times 1, 2. So 2 times 1 is what? 2. Let's get it straight. So 2 plus 1, what's that? 3. You understand? There's something. You understand now? So everything inside is 3. You understand what's happening? So let me remove the 3. So because of space, so here is 3 already. So 2 times that 3, what's that altogether? That's 6. So 6 electrons should be inside the p orbital. Class, this thing is simple. Just take your time. You understand? I believe you understand what happened here. They are very simple. Practice makes perfect. Look at what I did. First of all, I had to determine the L value for the p orbital. And what was that? 1. So this L now is 1. I had to put in a bracket to prevent stress. So we now wrote 1. So 2 times 1 plus 2. 2 times 1 is 2. So 2 plus that 1 is 3. So this 2 outside, that 2 outside is still outside. So that 2 times everything inside the bracket. So 2 times 3, that's 6 electrons in total. That's the answer. So the answer to the question for question number 24 is 6 electrons. So you should solve for D for me. Determine the maximum number of electrons in the D orbital. So you look for the D orbital and the L is 2. So solve based on that. It's very simple. It's not difficult. So let's get into, alright, so 26 you should solve as well. Determine the maximum number of electrons when L is 3. They just gave us L to be 3, so solve that as well. They did not stress you, they just gave you L. So solve for the maximum number of electrons when L is 3 is very simple. But for more understanding of the quantum number and learning other quantum number, because we have 4 quantum numbers, the principal quantum number, azimuthal, quantum number, magnetic, and spin. For this, learning these 2 other quantum numbers, you should watch my video lesson. Here is it after watching this lesson till the end. Now, let's get into the next practice question, and it says, what reactions does cathode undergo? There is an acronym you should understand here. The acronym for you to know the reactions that cathodes or anode undergo is called cryo. Cryo, all right. C and arrow goes together, A and O goes together. So the C and A, C is cathode, arrow is reduction. A is anode, O is oxidation. So cathode undergoes reduction always. It's on the topic of electrolysis, and I think I have videos on this aspect as well. So cathode undergoes reduction. Anode undergoes what? Oxidation. I believe it's clear. It's not difficult. It's very simple. All right, let's get into the next question. It says, the measure of the degree of disorderliness in the reaction, that's called entropy. The measure of the degree of disorderliness in a reaction is called entropy. You get that, all simple. Now, the next question says, the heat content of a reaction, they call it enthalpy. What's it called? Enthalpy. All of these, as well as Gibbs energy, we talk about the energy of a reaction. All of these altogether tells us if a reaction is spontaneous or not. This is on a different aspect in chemistry called spontaneity of a chemical reaction. But you should understand what we've said. They are all simple. Now, let's get into the next question. Question number 31, it says, when HP is higher than HR, HP is greater. So first of all, what's HP? Heat content of product. What's HR? Heat content of reactant. All right, what brought us to this, questions is on enthalpy change. As we're having enthalpy, so we're having the change of enthalpy. Enthalpy itself is symbolized as H. So delta H will not be enthalpy change because delta is change. And H already, we know that it's enthalpy. So basically, it has a formula that you must note, and it is HP minus HR. So you can see where H by HR is coming from. What's HP? Heat content of product. What's HR? Heat content of reactant. This is very simple. You should understand here that whenever in a reaction, the HP, heat content of product, is higher than the heat content of reactant, you simply say there is a sign that is assigned to delta H, which is enthalpy change. Whenever this happens, whereby HP is greater than H arrow, you tells us that this delta H is positively charged. I beg you, take note, take note. If HP is best, I draw all of these things, but I'm not. In more subsequent lesson, I'm going to explain all of these things. But you should understand here that when HP is greater than H arrow, delta H is positive. Well, when it is the opposite, whereby HP is lesser than H arrow, that means H arrow is not greater than HP. You understand now? Then your delta H should be negative. Please note all these. They are all very simple. Now let's get into the next practice question, and it says, what is neutralization reaction? Very simple. It's a reaction between an acid and a base to give rise to salt and water. So the next question says, the general formula for alkane. Remember, alkane is an hydrocarbon. Alkane is an organic compound. And the general formula for alkane is simply CnH2n plus 2. Notice, the JAM exam normally asks this. They will ask you, the general formula for alkane, was it? It is CnH2n plus 2. For alkene, their general formula is CnH2n. You stop here. For alkynes, their general formula is CnH2n minus 2. Note it, memorize it. It will help you. So I beg you, note all of these compounds' general formula. There are other forms of organic compounds and their general formula too. But it's very important I tell you this. So let's get into the next question. The question to 37 says, the ability of carbon to form long chains, that's called catenation. Whereby carbon is a tetravalent element, or is tetravalent. Yes, carbon is tetravalent. What does it mean? Carbon as an element allows 4 bonds to surround it. Tetra means 4. So carbon, the maximum number of bonds that should surround carbon is 4. If you are here and you're finding it difficult to learn how to name organic compounds, I already have a full video lesson on my channel that explains it. So here is the video. After watching this lesson, make sure you go watch that lesson on how to name organic compounds to understand what I just explained properly, because it's on the field of organic chemistry. Okay guys, let's get into question number 39, and it says, this is a compound. They are not asking what's the name of this compound. Very simple. It's simply the structure of benzene. Remember, benzene is an aromatic compound. From the word aromatic, it means that it has a good aroma. It smells nice. Are you there? And this benzene has a chemical formula, and the chemical formula of benzene is simply C6H6. I know you'll be wondering how. Actually, at every junction, there is a carbon. So that forms the 6 carbon. Carbon, 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 and carbon. So this carbon is bonding with just one hydrogen. And I believe you can see what I'm doing. So this carbon is bonding with what? Just one. So if you count all the hydrogen, it's going to give you 6. If you count all the carbons, it's going to give you 6 as well. So that is why it is C6H6. Are you there? Though benzene has brothers and derivatives. In more video lesson, I'm going to talk more on benzene and some other key things you should know. So we've come to the end of this lesson. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my lessons to friends. Thanks for watching.
Have more understanding about chemistry calculations and solving all of this type of questions. I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.